Hello guys, I'm Azim and I'm from Group 7 of Digital Electronic Design, and today we'll be doing Lab 2 basic circuits and I'll be covering part 1. So, as you can see from the report here, this is how the schematic should look like, and this is what the expected waveform should look like with the D input and clock input contributing to the Q output. Keep in mind that the Q output and Q prime output will always be of different levels, opposite levels if you may. And now I will show it to you on the circuit right now. For pin number 1 is the reset button and pin 4 is the set input. Keeping in mind that both are active low, we would like to keep both of these lights on. For pin 2, it is connected as the data input, and pin 3, it is connected as the clock input. For Q, it is connected to the pin 5 output, and for Q prime, the opposite of Q, we will be connecting it to pin 6 right here. Now, let me demonstrate to you. When data input and clock input is low, Q output is low, Q prime high. When data input is high and the clock input is low, data input high, clock input low, same result, low, high. Now when we put data input and clock input as high, Q should be high and Q prime low. Now when I put data input as high and clock input as low, the result remains the same. Q output is high, Q prime is low. When we let both to be low, data input low, clock input low, the Q output will be high and the Q prime will be opposite, which is low. Now when we have data input low and clock input high, the Q output is high, the Q output is low and the Q prime is high. When both is low, data input low and clock input is low, Q output will be low and Q prime will be high. When data input is high and clock input is low, Q output will be low and Q prime will be high. Similarly, when we have both when we revert back to putting data input as low and clock input as low, Q output will be low also and Q prime will be high. When the data input is high and the clock input is low, the same result as the previous 4 will come, which is the Q output will be low and the Q prime output will be high. And lastly, when we go back to making both inputs of data and clock to be high, we will have Q output will also be high and the Q prime will be low this time. Thank you. So now we're going to be looking at part 2. We'll be using 74HC74IC, and here's how the clock looks like with the expected waveform. We have used an input of 500 kHz and we are expected to get half of those values by 250 kHz. So here is how our circuit looks like. As you can see, we have connected 2 channels to the circuit to obtain the values on the oscilloscope. On channel 1 we get 250 kHz and on channel 2 we get 500, which was the original value.
Okay, for part 3 we are supposed to do the circuit that which need to count from 1 to 6. So from this K net, we know that we need to count from 1 to 6. So 1, 2, 3, 4, 5 are 1. However, when it counts to 6, it will become 0, and the rest are all in the cross. So it can be write that PE prime equals to Q1 prime and Q2 prime. And so this is our diagram. So this one is H74HC161, and this NAND gate will be 74HC00IC. So this will be our circuit, and our clock we just put 1 Hz, because 1 Hz is enough already. And when I press the button, it will start to count. 1, 2, 3, 4, 5, 6. So just now when we see that when it goes to 6, this light will turn off.
Hello guys, now we'll proceed on with part 5 of lab 2. In part 5, we'll be combining part 3 and part 4 in order to produce part 5. There will be no video for part 4 as we already included in part 5. This is the schematic diagram of part 4. And now we'll start demonstrating the circuit for part 5. We will be using 1 Hz to count. This is the run and stop button which control these two parts. But now we will be focusing on the die model. Let's start now. We'll start the counting now. 1, 2, 3, 4, 5, and 6. Then we will increase the frequency to 20 Hz. This will generate the random number, as you can see. With these electronic dice, we will be able to play any board games such as Monopoly. Well, this is the end of part 5. Thank you.